So now compute the distance to each of those classes you know, those instances you know which class it belongs to. And after you finish the computation, you identify a field, K, that's the K you want to identify, which is the closest to what you are looking for. And then, if these three all belongs to a class A, then you classify this belongs to class A. That's the idea. It's very simple. In here, the K equals 3. Basically, you pick 3. But how do you pick the K is experimental cases. You can choose KB1. That's called the traditional nearest neighborhood. K equals 3, K equals 5, K could be, any number could be very big. So in this case, K equals 1, and this is the case you're looking for. This is a minus class, then it's minus. This is a bad choice because you have the K equal 2, you get a 1 minus 1 plus, you get confused in which class belongs to, right? However, you can do that. You look at this minus class is near to this, right? Even if it's a tie, it's a draw, you can still classify this belongs to the minus class. You use the so-called reverse distance weight. You give this near distance a little more weight of the vote, right? And that's a possibility to solve that tie, to break the tie. And in here, the majority vote. 2 of them is a plus class, and 1 is a minus class. You can think about, okay, now belongs to the plus class, and do a majority vote. That's all your choice.
Excuse me.
Mm-hmm.
So you're using the nearest neighbors to predict class?
Yeah. But those you already know. You use those known example to predict the unknown example. Just like let's say, I'm the search committee chair. We're going to search a lot of candidates. And who is going to be hired next? And in our case, we, as the committee member, most likely we're going to look at all the known colleagues, the successful examples. And they try to put this guy, look at the resume, and put the to compare to somebody really close. Okay, this guy is also a Chinese and a graduate of such and such a college and have such and such experience. People usually, just like the book I mentioned, thinking fast and thinking slow, you always have a stereotype, and they try to use your new case to fit into the stereotype and they try to do which one is closest to your memorized stereotype. That's the same idea, and we just compare to the example I already know, and to see which one is the closest one, which 3 are the closest one, and if I have a favorite opinion, those 3, I say this guy is good, could be hired, or at least give an interview. But if I have 3 examples really look like him, bad in my expression, maybe say, hey, no way, and that's not what we're gonna do. So it's the same way, you know, that's just the quickest thinking is always like that. We look at the stereotype and look what's the closest one, not much of the rational. And how do you choose the K? That is experiment. Sometimes you choose the K a little bit, we call it evolutionary. A little bit of K equal 1, K equal 3, K equal 5, to compare with the test case. You have another set of testing sets to see which one gives you a better estimate. Then you pick up that K. So K is empirical solution. Empirical means you're going to test the test to see what's the test. So this is called instance-based learning. The instance-based learning, the train phase only consists of storing the feature of the vector and the class label. In another word, you don't have any model stored or anything. You just store the cases, the examples. And we really don't get a decision tree before we hire people. We just have a lot of stereo cases in our mind. Colleagues we know have the such expertise, personality, and combination, right? But once the new case come, we compare and look at the distance, how close they are, and that distance is the whole trick. And then to see how many k is there's trade-off there. So we need to, in theory, we need to look at the distance to each training case. But in reality, we don't really have to look at all the points, because you can have a rough, heuristic idea to figure out a lot of things far away, right? You look at a few attributes which are critical, you might need to be considered first. There's all different ways. Depends on how big training size you have. If your training size is 100 computer, that's a piece of cake. But if your training case like the galaxy hundreds of millions, you might need to select some. So in the end, most people choose the majority vote to see which class to select. What's the best choice of K? That again depends on your data, and it depends on your computation. Sometimes you really don't know, and you can try. Start from 1, 3, and all the way up to 9. Probably, usually we don't get it too big. I'm going to explain why it's not too big. So what's the good and the bad sides of big and the small? The large value of the K usually will reduce the noise effect. For example, in America jury system, and how many jury members you want? 7, 9, depends on case. 3 probably too small, right? Because 1 maybe have a too big a voice and dominating. And the 7 probably good size, but the important one could be up to 9. I don't know, murder case. And a little bit bigger, it always can help sustain the noise. Don't make one guy's too much voice, and also help for the overfitting problem. The overfitting, not too sensitive to a little change. But too large will make the class boundary less distinct. That means you include a lot of positive and negative class. Maybe when you have a little too big, how about you have 21? And you end up 11 yes, and 10 no. That's not good. That's not a good way, right? So you can empirically know that's bad, because maybe it's too big. And the whole bottom line is you really wanted to informative, like look at the clear majority. That's the goal, right? For any class. So how do you do the heuristic? You just do an evolution algorithm. Evolution means you can try and error to compare with the training case to see which can give you the best answer, or you look at the purity point of view. You remember the entropy, and each time you will say vote, how unanimous vote, how many unanimous vote, and how many predominant vote, and how many narrow win. If it's a narrow win, that's not good, right? So that's what it means heuristic, and you're gonna make a decision.